Yeah, so question 1, select all of the following graphs which represent y as a function of x. Yes, I agree with you, Syntax. So definitely that one. That one is definitely going to pass our vertical line test. So we're kind of looking, I kind of picture like a vertical line kind of scanning from left to right across the screen. So for example, this one here would not pass the vertical line test. So I know that it's not a function. But I think all of these other ones look like functions to me. Those should be okay. Yeah, left top, absolutely. That's like a sine wave. Kind of like an upside down sine wave. So that one should work. And then here at the bottom, this one looks like it's going to be okay. That one should pass the vertical line test, but I don't think that this one will. Nice and easy warm-up question. So now we want to talk about one-to-one functions. So which of the following are one-to-one? So whereas the vertical line test gives us information about whether or not it's a function, I believe the horizontal line test will give us some information about whether or not it is one-to-one. So we need to make sure they're functions first of all. So I know, for example, like this circle, this definitely isn't going to work because it's not even a function. So that definitely doesn't pass the vertical or the horizontal line test. So that's going to be no bueno. Now, I don't think this first one's going to be any good either, right? Because it's not a function. So even though it does pass the horizontal line test, it's one-to-one, that's not a function. And sometimes for relationships like this, there are techniques for kind of breaking apart these relationships into sections that are one-to-one, and then you can sometimes work with things like derivatives inside of these sections. Now, I do believe that this one should be... No, this one's no good. This one is actually no good, right? This one's not going to pass the... So it is a function, but it's not going to pass the horizontal line test. Hello, Anders. How are you doing? One-to-one meaning it has a single valued inverse function. Yes, that is correct, Syntax. So I think this one should be okay. This one certainly is a function, and it looks like it's going to pass the horizontal line test. So I think that one should be fine. What about our last two here? Parabolas, I know, are not one-to-one, right? They do not pass the horizontal line test. So it is a function, but it doesn't pass the horizontal line test. A linear function is one-to-one. Now we can always find a nice inverse function for a line. So that one should be okay. That's good to hear, Anders. That's good to hear. All right, chat. Challenging questions ahead. Question 3, find the domain and range of the function graphed below. Shout out to parabolas. Yeah, shout out to half parabolas too. If a full parabola is too much for you, just have a half parabola. Love me some good parabolic motion. Okay, so domain's the x values, right? It's been a long time since I've talked about this kind of stuff. So I'm here the domain is going to be our collection of x values that we're allowed to use as inputs for this function. It looks like the x values start at -1 and go up to 3. Now we have a closed circle at -1, so I want to put an equal sign here. There is no closed circle at 3, so I'm not going to include the point at 3. So this is one way to write our domain. We could potentially also write it in interval notation. So depending on how the Moodle shell wants you to input the solutions, it's going to be one or the other of these things. So that's going to be our domain. What's the range here? Uh-oh, what the heck? Invalid literal for int with Enigma, what? I think I broke Enigma bot. Uh-oh. What do our y values look like? It looks like the highest y value is 4. And we are certainly allowed to include that point. It looks like the lowest y value is going to be around -5. So yeah, so I agree I don't think we're gonna include that -5 though. So I think we're gonna have an open circle at -5. I think our range would look like one of the following. So if I have a function that involves a square root or an even root, I know that I can't have any negative values inside this square root. So I basically want to take -5x plus 8. And I want to ensure that this is bigger than... No, actually, let's find out... What should I want? What do I want here? What do I want to do? Basically, this is what I want, right? So these are all of the permitted values for -5x plus 8. It could be 0, that's fine. Or I want to make sure that this number ends up being a positive number. So I think this should be okay. And if we could solve for x, that should give us the domain of our function. So let's move the -8 over to the other side. And then we're going to go ahead and divide by -5. So that gives us 8/5. When I divide by -5, I do have to swap that inequality symbol. So it looks like x needs to be less than or equal to 8/5. So if it's 8/5, does that give us the 0? And if I take something less than 8/5, which would be like 2, no, that would be bigger. Well, I guess I could take x is equal to 0. 0 would be fine. Okay, so this should work for x. So we should have x less than or equal to 8/5. Or I guess we could write it as -infinity up to and including 8/5. Okay, what is f evaluated at -5? F evaluated at -5 is 3 times -5 squared plus 3 times -5 minus 6. That's going to be 3 times 25. 3 times 25, I write down a 2. 3 times 25 plus, nope, this is going to be minus 15 minus 6. So we need 75 minus 21. 50, is that 54? Does that sound right? 54? I do have a calculator, and I'm not ashamed to use it. Excellent. 54 it is. 54. Yeah. Oh my gosh, look at question 6. We have a parabola, 2x squared minus 8x plus 12. Find the following. F at a. Okay, this isn't too bad. So f evaluated at a is 2a squared minus 8a plus 12. We just replace all of the x's with a's. Now, f2 times f of a is just going to be the expression we wrote down. We just have to multiply everything by 2. So it's going to be 4a squared minus 16a plus 24. F evaluated at 2a, we might have to do a little bit more work. So f at 2a, that's 2 times 2a squared minus 8 times 2a plus 12. Okay, so 2, and then 2a squared is going to be 4. Oh, my pen's being funny again. It was working well. So 2, let's go 4a squared minus 16a's plus 12. So this is 8a squared minus 16a plus 12. Yeah, that seems pretty good. Okay, so 8a squared minus 16a plus 12. Next, we need a plus 2. So this is going to be 2a plus 2 squared minus 8a plus 2, and then plus 12. Oh, this sucks. So this is going to be 2. This is a squared plus 4a plus 4. And then we need a subtraction of 8a, subtraction of 16, and an addition of 12. So what do we get all together? 2a squared plus 8a plus 8. Negative 16 plus 12 is negative 4, I think, right? Those lusty calculators. So 2a squared, we're going to subtract our 8a's off. Those are canceling, give us 0. 8 take away 4 should be 4. So we're looking at 2a squared plus 4.
Simple quantum physics. Don't expect to grasp zeta insane concepts in a snap. Keep at it.
Oh, doing some quantum physics. That's kind of cool. I have never learned any physics ever. So I am actually a little nervous because I have no idea what mechanics is going to look like. I literally have no expectations, which is probably a good thing. We already have f evaluated at a. That's 2a squared minus 8a plus 12. So now all we need to do is add f at 2 to that. So we're going to add f at 2, which is 2 times 2 squared minus 8 times 2 plus 12. So we'll get 2a squared minus 8a. And then I'm going to get 12 plus 12 plus 8 minus 16. So 24 and 8 is 32. So 32 take away 16. I believe that's 16, right? And there we go. I think that's going to clear up question 6 for us. Which maths courses are you going to have at the same time? Hopefully one of them is at least like an easy maths course. Okay, so this is a piecewise function. We have two pieces. We have a piece that operates when x is less than 0. That's the 8x take away 4 piece. And we have a piece that operates when x is bigger than or equal to 0. That's the 8x minus 8 piece. We need to calculate f at -1, f at 0, and f at 2. So f at -1, we're going to look at the x value. This is our x value here. -1 is less than 0, so we're going to use the top piece to do our evaluation. And we should get 8 times -1 minus 4. So -8 take away 4 more, so -12. Next up, we're looking at 0. So again, we're going to look at this x value. 0 is going to fall on this particular piece. 0 is indeed greater than or equal to 0, so we're going to use the 8x take away 8 part, and that should give us -8. And then finally, we should be using, I think, the same piece here to evaluate f at 2. So that's going to be 8 times 2 minus 8. So 16 take away 8. That'll give us +8. So that should clear up section 1.1.